Hey guys, it's Kt.6 here, and today we're going to go over EKG Part 6. So, as I denoted here on the board, I wrote EKG Part 6 down, and while you are here, I do request that you consider subscribing to my channel, and if you do, please turn on post notifications. I would really appreciate it. And yeah, today we're going to talk about the electrical axis with an example I laid out. So, we're going to talk about electrical axis. And the thing is, when depolarizing or repolarizing a chamber, we create vectors. We can create some vectors. And these vectors sum up to show the total electrical force coming. And I said in the previous video, EKG Part 5, that we are going to define the electrical axis, and that's basically the point of the video today. And we're going to give an example about the ventricles. Ventricular depolarization with a QRS wave. And so we're in complete heart. I have the pen tool. My face cam is currently blocking that. You can see the pen tool and the undo tool. Okay, let's put our face cam back. And our first order of business is to draw the interventricular. We have to draw the septum. It's crude drawing, but still. And when we talk about ventricular depolarization, we have 8 vectors. And I'm going to draw them out. So that's vector 1, vector 2, vector 3, vector 4, vector 5, vector 6, vector 7, vector 8. It is an approximate because I'm drawing it. It's not like to scale, but that's like the vectors. And these vectors sum up. These vectors show, and the first one is septal depolarization. And the rest are progressively depolarizing the ventricle. Let's undo that. And these vectors can add up to, let's draw it on top using orange. We can take the mean or the average of all these vectors and get a mean vector. We're going to shade that in. That is the mean vector. And the direction of this mean vector is the electrical axis for the QRS complex, and that's defining it. Now we have to determine whether the axis is normal or not, and we have to go back to notability to determine that. So we can draw a crude heart. A crude circle. Okay, that is not good. Imagine this is superimposed on the heart, a 360-degree circle, 0, 180, negative 90, and 90 degrees. And this is superimposed on the heart. And we're going to talk about limb leads, actually. The lead will record a positive deflection if the wave of depolarization was moving towards it. We covered that like in a few videos ago. And we can use that rule. So lead 1 is at 0 degrees. And if the QRS vector is directed between negative 90 and 90 degrees, it makes it positive. So negative 90 and 90 degrees. Let's change our color. No. Yeah. Also, you guys can't see this, but that's my color switcher. Yeah. So let's use orange. And we can shade that in. And lead AVF, remember lead 1 is the standard lead and lead AVF is the augmented lead. So lead AVF is at 90 degrees. So this is where lead AVF was, and it is between 0 and 180 degrees. So let's use a good cool color. Let's use yellow, not a cool color. But let us shade in where lead AVF would show. They overlap, and in this overlap, this is where we find a normal vector. Let's go back and switch back to blue. This is the direction of a normal vector. And that is a normal wave. QRS wave. Yeah. But say the wave, we'll just change your color to pink, is like that. That is not normal. And I can show you an actual EKG wave, a wave like that. Let's go to a neutral color, gray, and we can show that to you. So if it's between 0 and 90 degrees, I want to re-emphasize this. It is normal, but if it's not normal. And I can draw waves. So this, I'm going to draw the blue wave. Actually, let's have it color coordinate. So this is the blue wave from lead 1. This is what it gets. And this is what lead AVF gets. Lead 1. Actually, this should be lead AVF. And remember, this is the normal one. And we go back to pink. And this is what lead 1 would look like with the pink one. And this is what lead AVF would look like. There's a stark difference, and we can notice that. And that's basically how we use the electrical axis to find out whether the QRS wave is good or not. And that was it for this video. I hope you guys enjoyed this video. We defined the electrical axis, and we use an example. And EKG Part 7 will be coming out soon. K85 out. Bye-bye. See ya.